of these bonds between these three oxygen molecules of ozone. And this is basically giving off heat. And this heat then is actually causing the stratosphere to warm up. So this is a really good thing, because this is shielding us on the surface of Earth from a lot of UV light. And you're probably going, well, so what? Well, UV light is pretty powerful stuff. It's high energy. Have you ever had a picture hanging up in your house, and it's been there 4 or 5 years, and you move or you decide to take the picture down, and darned if there isn't kind of a square on the wall where the picture was hanging. Everything else kind of bleached out, but that spot is still stands out. That's because the UV light was bleaching out everything around it, and that picture was protecting the wall at that point. That's how powerful UV light is. That's why paintings and posters fade out. It's not because they used lousy ink, it's because the UV light's breaking it down. Another thing that UV light does is it gives you skin cancer. How many times you've been out on a cloudy day and you go, oh, don't need any sunscreen today, it's really cloudy, no problem. And 2 hours later you come in and you're all sunburned. Yeah, it happens, doesn't it? What's happening is that UV light's getting through the cloud mass and cooking you, sunburning you, regardless. You don't see it, but it's happening. Do that enough, and all of a sudden skin cancer becomes a big problem. We've been having problems with a hole in the ozone layer that is kind of a seasonal thing, usually in the winter months over the South Pole. And this means more UV light can stream in and hit the surface of Earth. Well, I guess we don't have to worry, huh? It's not going to get us and give us skin cancer. But here's what it is doing. While that hole is open, Australia, which sits right on the edge of this ozone hole, is for the last few years showing skin cancer rates that are at least a minimum of 20% greater than the global average. And it's getting worse. So it's a little bit of a concern. Another thing that we're seeing is that these little planktonic organisms that float around on the surface of the ocean that form the very base of the food chain, their productivity has been significantly declining. They're essentially getting sunburned and cooked to death. And if that part of the food chain goes away, what's going to happen to the rest of the food chain? Yeah, this is going to be an issue. This is something that we need to really pay attention to. So, something that we need to consider. So the stratosphere, we start to see the temperatures warming up as these ozone molecules of 3 oxygen atoms get made and broken, back and forth. All covalent bonds, so they take a lot of energy. And that is protecting us from a lot of this UV energy issue. So ozone up in the stratosphere is a really good thing. It protects us. And we need to make sure that we preserve ozone up there and that the ozone hole is minimized and hopefully goes away. We've discovered that we're partially or mostly responsible for that ozone hole. We've been putting gases into the atmosphere called CFCs, chlorofluorocarbons. These are the gases that run your refrigerator, your air conditioner. But the thing is, they accelerate, they act as catalysts to break down ozone. So when they're up in the atmosphere, not so good. So we've banned the manufacture of most of these CFCs, and we have made it much more difficult now to work on refrigeration and air conditioning things so that we don't let that gas escape to the atmosphere. That's part of what we're trying to do. And it is starting to make a difference. The problem is it's about a 50-year time frame before we see any significant change. But at least it's leveled off. We're just maybe starting to see the beginnings of a drop-off. So we're hoping we're on the right track. Now, ozone, if I have it down in the troposphere where we live, not so good. Because now, instead of being our friend, it's our enemy. Because you know ozone in the troposphere is smog. And things like gas exhaust, and pollutants, all that brown haze that you see in the pictures, that smog is ozone. And for us, yes, it's protecting us from the UV light, but our lungs don't like ozone very well. And it creates all sorts of internal respiratory problems. So, you know, ozone is kind of one of these two-edged swords. So if we look at the heat coming in from the atmosphere, from the sun, it's coming in as UV rays, this really intense, high-energy, shortwave radiation. It hits Earth, it warms up Earth, and much of that energy then radiates back out into space, but it does not go out as UV. It goes out as infrared or IR, which is much lower energy and longer wave radiation. So whereas the shortwave UV radiation can kind of sneak in between molecules and particles and clouds and all that, the long wave IR can't. So when it's trying to radiate away from Earth, it runs into these other molecules and it gets reflected and bounced back to Earth. That's our greenhouse effect. And that's where CO2 and, believe it or not, water vapor are really very effective. Okay, so what are some of the consequences of global warming? So what? I can stand for it to be a couple of degrees warmer. Do I really care? Well, I probably ought to. Because this is going to be a long-term trend, and it's not going to change overnight, regardless of what we do. It's going to definitely alter the distribution of the world's water resources. This is big. We can live without oil. We can't live without water. And as more of us have moved to the southwest part of the United States, their water issues have become crisis proportion. And I will predict that over the next 20 years, you're going to see water become the new oil. The prices you saw for oil are going to be prices you're going to be seeing for water. Water is going to be more and more important. And Michigan, with 4 of the 5 Great Lakes as its borders, is going to be in a pretty nice place. I think it's going to start shifting back to the states that have the water. That's going to be big. And the thing is, the states that have the water then have that added responsibility that they've got to take care of it. If they want things to come back, that's going to be the biggest draw they have. Right now, the Michigan Geological Survey, their #1 priority in Michigan, groundwater, for a good reason. We're going to see sea level increase. The glaciers are going to melt, right? The polar ice caps are going to melt. That water is going to return from sitting on the land as ice, is going to run off and return to the oceans. The ocean level is going to go up. It's probably going to go up about 20 feet if we melt all the ice. 20 feet drowns out pretty much the whole East Coast, pretty much most of the Gulf of Mexico. All the big cities in Texas up to Memphis, Tennessee are underwater. Now, are we going to let that happen? No, we're going to put in dikes, we're going to put in systems that protect the cities. We're not going to let them just get drowned.
On one of the exams, there was a question. It was like, is the Earth getting warmer, or the Earth is getting warmer? And the answer was actually false. Why is that?
The Earth itself is not getting warmer. The atmosphere in the ocean is getting warmer. Okay. But Earth is losing heat as a body.
But the atmosphere is gaining.
Yeah, the atmosphere is gaining.
Okay.
And the big thing that we've been able to measure that we know is the world's oceans are getting warmer. Now with satellite thermometry, we can measure the temperature of the water, and then we have ships out there that are taking water samples and measuring the temperature. And we can then measure the same spot with the satellite, and we can calibrate the satellite to the ship, the actual measurement, and use that calibration to then measure the whole ocean with the satellites. And after doing that now for about 15 years, we've seen an increase in the overall temperature of the world's oceans. So we know it's getting warmer. So, sea levels are going to go up. Now, immediately you're going, sure, because all the ice is melting. Actually, in some places, the ice is growing because it takes a little more temperature to get more moisture in the air, and it takes more moisture to actually have snowfall. You can have a cold area, but if you don't have any moisture in the air, nothing's coming down, right? So a little warmth in some of these areas actually increases the snowfall, which increases glacial growth. The biggest thing that's happening with the oceans is the change in temperature. As I heat the ocean up, the volume expands. And that is the main reason that sea level is going to increase more than the addition of glacial melting. It's simply warm the water expands in volume. Okay?
But even if we did put in like seawalls and dikes and whatnot, if the sea level rose, wouldn't we just have like a hurricane like Katrina where something is so much further below sea level and it would just wipe them out because they'd have nowhere to drain?
Sure. Well, we'd be pumping, we'd be draining, yeah. But yeah, I mean, it's going to certainly add to the cost of infrastructure. They're doing it in Holland, have been for centuries. We've been doing it in New Orleans for a couple centuries. New Orleans, for the most part, is 3 feet below sea level. When you stand on the dikes in New Orleans along the Mississippi River, and you watch the big Atlantic freighters go by, the bottom, the keels of the freighters are above the level of the streets in New Orleans. Yeah, you don't realize because you're up on this big levee, but it's actually kind of built up over the years to where New Orleans is way below sea level. They have a whole pumping system that keeps New Orleans pumped out. It's all infrastructure. So there's going to be more of that in more places, more money, and damage when it goes down, for whatever reason. We're going to see weather patterns change. And one of the good things here is we grow lots of crops. What if, on average, it goes up 3 degrees? That's going to really expand our growing season, isn't it? We might be okay. Or our fruit industry might kind of shrivel up and die because it's just not equipped to handle those temperatures that long. But will be great for corn. But right now, with genetics, we can shift the crops that we put in. For instance, this year, all the farmers are going to originally plant 120-day corn. The genetics are set so that it comes to full maturity in 120 days. But it was so wet, and they couldn't get into the fields, and they all shifted at the last minute and put in 90-day corn. So all the seed companies, had 120-day corn ready to go. And now, all of a sudden, everybody needed 90-day corn, and, there's only so much seed corn out there. So things really got changed at the last minute. So the seed companies are having to rebalance and rethink the way they prepare for these growing seasons. And you can bet they pay attention to this real big time, because you can only get away with it so many years, and then you're in trouble. So we're going to see higher frequency of hurricanes, we're going to see more intensity of hurricanes. And you've kind of been hearing that vibe ever since Hurricane Sandy out in New Jersey, right? And, you know, this one isn't proven. There's a lot of data here that still is kind of on the fence. It sounds logical. And we've certainly had a few really nasty storms, but how much of that nasty storm stuff we've seen lately is just part of that 20-year cycle of climate? And how much of it is really global warming? So that's the big issue, is how do you separate that? It's not always easy. But it would make logical sense that that is something we should be collecting data on and looking at. Because obviously hurricanes are fed in the tropics by warm water. You warm up the water, you're going to get more moisture in the air, you're going to get more hurricanes, and they're going to get bigger. It's a logical step. So you're going to see places that never had hurricanes before, maybe they're going to start being on the edge of the cyclonic tracks now, and you're going to see areas that aren't prepared for it. All of a sudden, they're getting whammed. That's going to change. And one of the big things that we have seen in the last couple of years are heat waves and droughts. And they're back big time out in the Southwest. Look what's happening in California in the last 2 or 3 years. And look at the number of forest fires they're having out there in the last 2 or 3 years. All-time records. So yeah, this is something to think about. This changes everything. And some of it might be a little on the subtle side, and it's only when you look back 20, 30, 40 years later that you kind of go, ooh, that wasn't like that when I was a kid. So, you know, I kind of get away talking like that because I've got all these years of experience. You know, in another 30 or 40 years, you'll be talking to your kids and kind of go, yeah, man, I remember all those nice spring days we used to have. No hurricanes.
And have a hurricane Michigan.
And then you won't be in Michigan. Okay. Good place to maybe call it quits today. Give you a couple extra minutes. Look for your midterm grade tomorrow. It'll probably be early afternoon before it shows up.
I know you said I got a bowl of you guys tell them to stop for your tattoo tonight, bro. And this one.
Good. How about you?
I'm doing well. I emailed you the other day regarding training ideas.
Oh, yeah.
So essentially, do you want me to explain the situation?
Yeah. What's going on?
Okay, so essentially, I had to go to, I work for Best Buy, and they sent me to a regional training meeting, and I had to go to one in Grand Rapids.
Oh,
So I could attend midterm, and
okay.
I have a letterhead from my general manager to show you as well.
So you need a mission.
Exactly.